Stupid floating rocks. You'll learn to respect gravity, you little bastards. And this is all just like trash assets at the moment. So, you know, it's not like I'm trying to make like a super awesome little mushroom house thing. I am very confused as to why this is here. Do we have a bug somewhere in this where we have negative to positive here? It's interesting. It's interesting how this is going. Let's see how these things are moving. I think that looks correct though. So I think we might have what we kind of want with this sort of thing. You know, like it's looking pretty good. Like, you know, we could have like multiple lines here if we really needed to. But, you know, if we drop something in the water here or whatever, you know, like we're gonna be able to blur that out and everything, and this'll do fine. We might want to increase the amount of random particles though that are getting spawned into this area. I think that might be a good idea. It's not 102, but whatever. And what else could we could draw a few things in here. Um, and so let's draw to the red channel. So the green channel is the age of the object. The red channel is going to be the velocity, and the blue is just going to be blue. So we should see a little bit different sort of thing happening here. I'm not seeing any. Oh yeah, this needs to be multiplied by 255. I was like, why is there no red? I was like, oh, it's from 0 to 1. The value needs to be from 0 to 255. Well, that'd do it. And I'm doing it on the exponent, so as it approaches maximum velocity, it's going to become much more red. So if it's moving slow, it's going to appear dimmer. Even though it's not really that much dimmer, it'll be exponentially dimmer. Because you know math. Yeah, Quentin, you mentioned that you're coding there. What sort of stuff are you working on? Anything interesting? All right, so let's get this thing actually rolling along here. So we should see our speeds here and how that works. No, that's not really what I want working on here. Yeah, as a server engineer for 8 years in the game industry, so complex of services working together for a big eShop. Yeah, that's that's how it works. So these velocities aren't really what I want, because these accelerations aren't really working. What I think I need for like the velocity is not necessarily the velocity. I need the like average history of movement of the object. Because if I was trying to get like the speed of, you know, all this sorts of stuff, you know, the velocity of these whiter things is faster, and like we're seeing like a lot of fast water over here. You know, we got like a bunch of fast water kind of in the middle. You can see it's clearing out. And I guess, no, the redder is faster. The white is going to be what? Oh, white is old and fast. You're doing game dev for fun in your free time? That's cool. Because these things that are you know, quote unquote have high velocity does not actually mean that it's moving quickly. I don't know. I think I need to take the history of that object and compute like a color based on that. Red colors are well, let's think about this. Like, if we keep running this simulation, what does everything really look like? If we just take it at face value, if we average all this together, we've got like a whole bunch of slow new particles, and we have some fast old ones and all that, but it's just kind of all over the place. You know, it's not doing too much. You know, if we average these out, these are, you know, they're moving, but they're not moving that fast. And their directions are all going to be like all over the place. Kind of they're going to average out to almost nothing. So that's okay. And all these guys are like moving fast, and some of them are new, but it would definitely have like a clear channel of speed and direction sort of stuff. You know, it looks like we would have some interesting things with the rocks. We do have the avoidance here. Well, let's take this tick. I like this texture. That looks kind of crazy. Let's just see what happens if we export this and blur it out. Something like that. Yeah, that's not too awful. Like, we'd have, you know, all these sorts of things going on. What are you doing this for, some project? Yeah, I'm working on this game. Give you a link to it real quick. Working on this game, Dashkin, and yeah, there's a lot of stuff for Unreal with water, but you know, as with a lot of game dev, like you can try to use stuff out of the box and, you know, purchase things. But I found that a lot of the time when you go buy stuff, it doesn't really do exactly what you want. And you end up with stuff that looks disjointed, and then also you can't really crack it open and customize it too well a lot of the time. So if you're not using it exactly how it was intended to be used, it doesn't work. And you could spend a lot of time trying to get something to work that you paid for, and really fail at getting it to work. So kind of what I've found is that assuming you can buy stuff is kind of a trap in a lot of times. So I've been kind of looking at those as references as to like kind of how, like, what sort of, you know, you look at it and you're like, okay, well, they have shore detection in there, you know, how'd they do that, you know, and then, okay, they have waves, and, you know, how did they do the waves? And like, okay, well, they use tessellation and vertex, you know, stuff like vertex displacement inside of the material, and then you look at it and you're like, well, tessellation only works on Windows, you know, like, or DirectX 11 compatible things, so it doesn't work on everything. And so a lot of it like will look pretty, but it's not like really production ready. Also, if you knuckle down and do it yourself, you can always fix it and customize it. So that's why I have enough time. Like, we're not on like a time crunch to ship this game, like in terms of, oh my god, if we don't ship this game in December, then, like, you know, I'm gonna have to, you know, sell half of my house and, you know, join the Salvation Army or something. It's more like, you know, we can take some time and actually make this good, so it's worth it. So kind of a long explanation, but that's my story. Sticking to it. I'm gonna take the average noise level. So instead of this being the velocity, alright, so noise plus equals pause and pause. So we've got our noise right here, actually. Let's just have a noise value here, and let's add in the distance. So what we want to do is, for every position here, let's see, it's going to be max noise. So noise plus equals m pause minus pause dot distance, and then max noise is gonna plus equal m max velocity, because that's like the greatest distance it can travel. So why don't we just make this a float, and this is going to be r value. Let's just make it color.r equals noise divided by max noise multiplied by 2.5. So that'll basically tell us the noise level of this thing, if it has a position and all that, if it actually got to move. Oh no, it's the light thing. Maybe he even uses spaces instead of tabs. Who doesn't? Yeah, well, you know, everybody's got their own programming preferences, and if you got 5 engineers in a room, You'll have 5 different ways to do something. Oh, it's not distance, it's size. That's why I was like, wait, what? Get distracted. Issues auto-detecting the IDE is what they use. Yeah. Yeah, everybody does stuff differently. So, you can get into holy wars about it, or you can just get your job done. And since, like, you know, doing like server engineer stuff, I'd be working in Visual Studio for the game, you know, which usually be in C++ or Flash or whatever the hell, requiring, you know, like Flash Builder or and then working in like Eclipse or IntelliJ or whatever for server code most of the time, and then working, you know, in other things for Python or whatever else for the code review tool. Just like at the end of the day, I don't even care. I'm just like the default settings of whatever the hell I'm using are probably good enough. I could spend 2 million years customizing everything, but then when I like, you know, have to switch a project and get everything set up, then I have to spend 2 million years customizing everything. So after a while, I just stopped caring about literally everything. The only thing I do to customize the editor is I remove the damned rebuild and clean buttons from things, so I don't actually press them. And then I just turn off like all the autocomplete because I hate autocomplete on things, especially when it doesn't work very well. Because like you'll be looking at another piece of code right below something, and like the autocomplete will pop up and be like, oh, you know, you should, you know, here's the IntelliSense, or the autocomplete will like throw in some quotes or something, and because I use all these different editors, they all do it differently, and you just get tripped up while you're typing. It's just like, screw it. Alright, so we should be seeing the noise, the particles that are purple here are, they've been able to move. So let's see if we keep ticking this, if we see the motion that we want. So we're trying to make sure is that like the motion of particles stays pretty good. Like, you know, the water here is not moving as fast as the water here, which is what you'd expect. Like, you know, water is going to kind of build up around a rock and then flow around it and get kind of stuck on a rock. You know, and this stuff doesn't have to be perfect. You don't understand the blank spaces. This spot right here is a destination. So it has no particles in it. So, you know, these particles over here and all that. So this is where we're spawning stuff right here. And we're detecting shore. This blank spot here, like I can look at the height map and you can see there's something right under the water here, which is this thing, which is actually right there in the way. So there is something in the water, and you can see this thing down there. if you want to see the actual shore distances, like these are the distances from shore as calculated by stuff. So there's like, you know, stuff right under it. So it's stuff like that. We're combining a whole bunch of textures and information together in order to actually do this. So I'm pretty happy with how this is looking. It's like, I think we've got the information we need. If we normalize the speed of the water and everything else, we could totally blur this together, and what would happen is water's moving fast here, and you know, if we were a leaf floating along, we would kind of, it looks like, kind of go like this. And it doesn't have to be absolutely perfect. We might get thrown off around here and kind of do whatever, like if the leaf had momentum and also read the flow field that it was sitting on. And if we blur it all out, it should not be too awful. So we're not trying to make, you know, the world's best water simulator. We're just trying to make the water simulator that doesn't just absolutely suck. So let's edit our blueprint real quick and up the number of ticks that we do. Let's up the number of ticks to 100. So it took about a minute, or just under a minute, to do that. And that number of ticks kind of looks like it's stabilized and everything. Let's see how long 50 ticks takes, and if there's any significant difference. How many ticks should I, you know, throw on this thing for just the default, you know, construct the static flow field and tick it the default number of times to get a basic idea of the simulation. And that doesn't look much different at all from the 100 ticks. So I think like 50 ticks is probably plenty. Let's just give it another 50 and see if there's any differences that pop out. I mean, this gets filled in with a lot of information, but that's not necessarily good information. That's duplicated information that we don't really need. Alright, I'm going to be right back, and then I'm going to try moving this geometry around, kind of make a snaking path and some other crap, and see what it looks like. Alright, well, let's see what we can do, throwing some obstacles in the way here. And see what our stuff does. So let's throw something like right in the middle. Here. Let's see, is the collision on for this? It's on for default. So we'll try 50 ticks. So we can see how that changed how the water flowed around this thing. Looks like most of the water just went straight for it. That looks fine. I'm not too worried about that. It looks, you know, like kind of went around it. That works totally fine. Let's give it another 50 ticks and see if it fills in any of this information. So yeah, it looks like it did fill in a bit of the information. So maybe we should have like 75 ticks as our actual value. Alright, so it looks like it kind of successfully did that. Let's build like, you know, a trap. Whoops, that's not correct. Let's build like a little wall here, and let's see what happens. Let's see if this thing can deal with the wall. So get 75 ticks. Alright, so what it did is we've got this massive buildup of water here, and then everything kind of skirted around it. And this is not a simple wall, right? Like, this is a complex wall. It's got these damn traps in it because it's actually using, you know, all that information. So that it even made it around it is actually pretty cool. Right, let's build a little tunnel. Also, let's make these teeth a little bit easier to deal with here. Let's turn these teeth into potatoes. Alright, let's see what this does for us. And that's kind of what you'd expect is, you know, we do have some water trickling off over into here. And it's moving fast, like that the red means it is moving quickly. So let's see if, because our pathfinding algorithm should find the correct path and spawn particles along the path properly for us. That's just kind of what it does. Thank you for following Quentin Cafio. Alright, so what in the hell happened to this? Let's move this real quick and see what. I guess. Something must have happened with our pathfinding got stuck in a wall or something. Maybe there's not enough resolution on that map to make it look good. And it's not like we have to make this thing absolutely perfect and handle all these cases properly. We just want it to be like, you know, you don't have to like, you know, walk on eggshells to make a little water area in this game. You know, just like, oh, don't put like a U-shaped thing between, you know, the river and this in the middle of the lake because then everything goes to hell. It legitimately looks like the pathfinding for this stuff is... Okay, what's probably happening is these particles aren't able to go anywhere because like they get stuck in this narrow channel. Well, that's okay. Let's do some other stuff. You know, we don't have to make the channel finding algorithm. But we do want to support like a winding river sort of situation. But it doesn't have to be super narrow. You know, we just have to support winding. So let's you know do our tower defense setup here. I don't know. Did anybody else play that like desktop tower defense when it came out online? It was like some Flash game that was just ridiculous tower defense. That was fun. I spent way too much time in college, and like level 50, wave 52 was air, and like you spent the entire goddamn map, like every wave up until that point, preparing for like the air wave, where like the stuff would come through, and like if you didn't have everything perfectly tuned for that, it would blow you up. It was always a lot of fun playing those sorts of games. Because you'd build like this awesome strategy. You're like, all right, I'm gonna, you know, do all this cool stuff, and then all of a sudden you get totally screwed. You're just like, oh man. The water didn't want to go on the path that I gave it. It found a different way around. Found a way around back. That makes perfect sense. Crafty little bastard. Never too many games like this. Yeah. Is it starting to work? Yes, Lucas. It is. It is starting to do what it should. So I'm testing out different configurations of shorelines and obstacles in the way, and to see kind of how the particles are performing, and also trying to figure out like how many ticks that I need to give the simulation to generate a decent field. Flash would crash. Yeah, that's how you do it. All right, so here's our winding river, and we've got like a whole bunch of water gets like stuck and roiling over here, which is really cool. I really like that. And then this water like makes a beeline over here, and some of it gets like smashed against the rocks, as you would expect. You know, like we're pumping water in here, it's gonna blam over here and, you know, make its way over here, get kind of all weird wishy-washy crap. You know, these things are moving real quick, and then it's gonna come and just go straight into the hole over there, and it's not getting stuck, but you can see there's some fast moving pixels over here, and all that. And this water, like this is a drain right here, so you would expect this water here too to be moving towards the drain, just because. And it's, you know, slowly these things are moving around. So I'd say we're looking pretty good for this water simulator. Let's put in our second outflow and see how that works with the pixels. Let's also make it a little bit more complicated. That texture looks really cool. You know, it's like that's where the water spawns and that's where it drains, and you know, you can totally see like where the rocks are and where like all the turbulence and crap is. And inside of our shaders, you know, we're going to be able to use that information. So let's go add our second outflow to this thing. The rocks look like a colon, I swear to God. Well, I'm sorry, Entropist. It's everything in game development. When you're putting stuff together, it always ends up looking like something obscene. It just always happens. You spend all day drawing a picture, and at the end of it, you're like, oh man, look at this awesome picture, and somebody's like, dude, there's a gigantic dick in the middle of your picture, and you're just like, God damn it. And this was the block of code I wanted to uncomment. We're going to take our ticks down to 1, and we're going to walk through the simulation a little slower just to see how it works. With multiple things, because the random pixels actually get assigned to a specific outflow, and I don't think I want to do that. I think I kind of want to just pick the nearest outflow to our random pixel and try that. But that's going to be wrong too, right? Because it's not really correct, because that distance might not be real distance. But the random pixels are random. That's kind of what they're supposed to be. Oh yeah, well I need to edit the blueprint to take those ticks down to 1. Well, that's interesting. Why aren't we, so we have an outflow over here, and we have an inflow here, and we have an outflow over there. We do have this random line that appeared, a break there, which meant that something wasn't able to spawn in a particle. So let's take a look at our code for spawning in a particle real quick. So we go through every flow field. And go around this thing. So we call try spawn particle. Aha, see this is wrong, right? This needs to be and. That'll get rid of our weird shenaniganry that we were seeing there. And what I'm going to do is I'm also going to have these... We're going to pick a random location here, and we're going to go through every flow field path. So we're going to do like 4 calculated flow path. Yeah, we'll do like int32 best flow path index equals like 1. 52 like 0 is less than flow field dot in paths dot num ga plus plus. All right, let's see the Is there a float max in this thing? Let's see. Does Unreal actually have a float max defined? Maybe it's called max float. Alright, so it's T numeric limits float max. Alright, cool. Alright, so let's grab that flow field, flow path. Alright, so if path.m found path equals false, we'll just continue. Otherwise, we want to get the distance, so that's going to be x minus path.m ex times x minus path.m ex plus y minus path.m y minus path.m Alright, so float dist equals this if dist is less than best distance equals dist, and best flow path index equals j. So if best flow path index is less than 0, continue, otherwise flow field in paths. So best flow path index ex. Is this a function? Alright. That should be good enough. So our random pixels will pick the closest outflow to go to. It may be wrong, but you know, whatever. And we've at least fixed our issues with spawning those particles in, which was screwing stuff up. I was wondering about that earlier when we had some kind of gaps in the spawning of the particles with the kind of snaking setup. But as soon as I saw that gap, I was like, yeah, that's just like I'm not checking both axes properly. And we could go through and probably optimize this entire thing if we wanted to, but this is all like static generation code crap that is also an experiment to see if it'll even work. So I'm not going to spend a whole lot of time worrying about optimizing something that I might just chuck in the trash can in 5 minutes. So let's build it up. Let's tear it down. I can see light outside. It's happening. It's becoming morning. Yeah, and if people are wondering exactly what we're trying to make here, is the overall thing that we've been working on for a couple weeks is figuring out what our visual look is going to be and then how to do that in Unreal. And this is the concept art piece that we're basically working towards slowly, and we're doing it one chunk at a time. And I'm roughing it out with like horrible crap assets, and Adam's the artist. He can go back and then we'll know what technologies we need so we can make some final assets that don't, look like potatoes. They at least will look like baked potatoes or even sweet potatoes if Adam has his way. Alright, so we don't have any gaps, and let's tick the simulation a little bit. Yeah, that's looking like what I want. I mean, theoretically, if we wanted to be super amazing with our water, we might want to change how we do our A-star distance calculation so that it actually takes like the short distance into account as well as the distance cost, in which case the pathfinding algorithm might actually find like a little gap here and try to stay in the middle as opposed to just finding, that shortest distance path around. So, because we got like a thing here which you would expect kind of the flow to go like this. But at the same time, this isn't... This actually looks fine. This spot may look real odd, because we don't have any pixels that are actually like the heuristic for these guys go towards, this destination that they're trying to go to, and they're not getting repelled enough by their surrounding neighbors. And we don't have, like, none of these pixels here are helping. Like, they're all making the flow go towards this thing because all the random pixels were like, oh yeah, I'll go over here. Well, we don't really want that, so maybe we don't want the random noise to be quite so random. Well, let's see if more particles fill it out a little bit. It looks like they might be filling out. Let's actually throw like 75 ticks at it and see what it looks like at the end of it. So this might take a little bit. Since we have two nodes here, it's actually going to spawn a lot more particles. Alright, I believe what I'm going to do is I'm going to work on that A-star algorithm real quick to have it try to path a little bit differently. I want it to try to path in the middle here. So where is our, I think it's like cost equals, yeah, we got this new node distance plus heuristic. So we want to do h plus equals, and then we want to look up the short distance calculation. So that's going to be